Okay, so in this video, we're going to take a look at how we can express numbers as products of prime factors. And we're going to use factor trees to help us do this. And all of this wording might seem a little bit daunting at first, but once we dive into a couple of examples, it should make a little bit more sense. So let's start off with revising what is a prime number. So remember that a prime number prime numbers can only be divided by 1 and itself. Okay, so that's the definition of a prime number. And can we think of some examples? Well, the number 3 can only be divided by 1 and 3. The number 5, the number 7, 11. Okay, but if you think about a number like 12, well, 12 can be divided by 2. Okay, 2, 4, 6, all of these numbers go into 12 as well. So that's not going to be a prime number. So 3, 5, 7, and 11, they're examples of prime numbers. And well, what about factors? What does factors mean? Well, factors are the numbers that can go into a number of choice. So let's take the number 12. What numbers go into 12? Well, we've got the number 1, the number 2, the number 3, the number 4, the number 6, and the number 12. So all of these here, these are all factors of 12. And as per this part here that says, I'll do it in blue, prime factors, okay, we're only going to be interested in this video about the particular factors that are prime. So prime factor number 2, number 3 are the 2 prime factors in this case. So let's dive into an example where we're going to look at a factor tree and hopefully we can all tie this all together and it'll make a little bit more sense. So let's look at a factor tree. So we need to pick a number. So the number 60 is the number that we're going to pick. And we want to express this number 60 as the product of prime factors. So how are we going to do that? Well, we're going to pick 2 numbers that multiply to give us 60. And then we're going to keep going down until we get to prime numbers, which we will then circle, and we don't have to go any further. So let's do it. So 60, 6 times 10 gives us 60. Okay, are either of these prime? No, they're not. They can both be divided down further. So the number 6 could be 3 times 2. Okay, are either of these numbers prime? Well, they're both prime in this case. So let's circle the prime numbers. We now don't have to go any further, so we leave those as is. What about the number 10 though? That can be divided into 5 and 2. So 5 times 2 makes 10. Are either of these prime? Again, both of them are prime, so let's circle both of them, and now we have completed our factor tree. Can we do another factor tree though for the same number 60? So instead of picking 6 and 10, is there another 2 numbers that multiply to give 60? And there are. Let's go with, in this case, the number 2 and the number 30. Are either of these numbers prime numbers? Well, the number 2 is, but the number 30 is not. So we need to go further with the number 30. And I'm going to pick the number 15 and the number 2. Are either of these prime? The number 2 is, but the number 15 isn't. So we need to go further again. So 15 could be divided into 5 and 3. So 5 times 3 gives us 15. Are either of these prime? Yes, they both are. Now, what do we do with this? Well, over here, this tells us that 60 is equal to 3 times 2 times 5 times 2. And over here, 60 is equal to the numbers that we circled, 2 times 5 times 3 times 2. So it doesn't seem to matter how we do our factor tree, we're always going to end up with the same prime factors multiplying together to give us a number that we started with, our 60. Now, from the indices video, before this video, we can simplify this down a little bit. So 3 times 2 times 5 times 2. But we have 2 2's here. So remember from the indices video that it doesn't matter what order we do our multiplication in. So let's group our 2's together and all of our 3's together and then all of our 5's together. And well, 2 times 2, base number of 2, and it's being multiplied by itself twice. So it's 2 squared times 3 times 5. So the number 60 is equal to 2 squared times 3 times 5. And that is the simplest way that we can write the products of our prime factors. And let's do the same over the other side and see if we get the same answer. So can we put all of our 2's together? 2 times 2 times 3 and then times 5. And well, this is 2 squared times 3 times 5. So once again, it doesn't matter what way we do our factor tree, we always end up getting the same answer. So can we do another factor tree example? I'm going to go with the number 40 this time. So let's put the number 40 in. So 40, and this can be divided into 20 and 2. Are either of these prime? Well, the number 2 is prime, so we can circle that number. What about the number 20 though? This can be divided down into 10 and 2 again. 2's prime, 10 isn't, so we circle the number 2, and this number 10 can be brought down into 5 and 2, which are both prime, so now we're finished. Is there another way, though, that we can do the same factor tree for the number 40? And there is. We could do the number 10 and the number 4, because 10 times 4 give us 40. And well, neither of these are primes, so we need to put them both down further into 5 and 2 for the number 10. So 5 times 2 is 10, and the number 4, 2 times 2 is 4. And all of these are prime, so we can circle them all. And let's write our final answer. So for this factor tree on the left here, 40 is equal to 5 times 2 times 2 times 2. And for the one on the right, we have that the number 40 is equal to, it gives us the exact same thing. Once again, 5 times 2 times 2 times 2. And we're lucky in this case that we don't, the particular way that we've done it, we don't have to rearrange these. Okay? Now, this could be written if we group all of our 2's together. So base number 2 repeated 3 times, multiplied by itself 3 times. So our final answer, 5 times 2 to the power of 3. And on this side, once again, the exact same, 5 times 2 to the power of 3. So, back to the original part here, expressing numbers as products of prime factors. So if we wanted to express the number 60 as a product of prime factors, our final answer would be 2 to the power of 2 times 3 times 5. They're all prime numbers, and you multiply them together. 2 times 2 times 3 times 5 gives us 60. And down here, if we wanted to express the number 40 as product of prime factors, we would do 5 times 2 to the power of 3. That would give us 40.